the session first can do so. Thank you
Sure,
very much.
Kasi. Okay, so before starting the session, I would have appreciated if you all have watched the video which I have uploaded, because we will be building upon on that concept, but most of you have watched it, so we will start with it. So I will start by sharing my screen. So I hope now you all can see my screen, and we're going to start with our section with the quantitative research, and the section 5 that will be the basics of data analysis. I will be conducting this session if the pace is too fast or slow for you, so you can message here, or you can stop me in between and ask question, because this will be a hand-on session, and I'll be showing you how to analyze data in SPSS along with explaining. So let's start with first, what is statistics? So statistics is the science of organizing, summarizing, analyzing, and drawing conclusions from the data. With this basic definition, I would like to move toward the basic definition which are used in stats and as well as in SPSS. So what is population? So population are all the atoms of the interest. Sample is a subset or a unit of a population. Experimental unit, that is an object upon which we collect data. While data is the value that a variable can assume, collected facts and figure. Variables, property or characteristics of people or things that vary in quality or magnitude from person to person or object to object. So whole of the SPSS and stats is based on variables. We classify variables into qualitative and quantitative. Qualitative variable are also known as categorical variable, while quantitative variable are also known as numerical variables. Qualitative variable are further divided into nominal and ordinal, while quantitative is divided into discrete and continuous, while the continuous is further divided into interval and ratio. We're going to discuss each of them with an example, then we will move towards SPSS. So qualitative variable or categorical variable. Qualitative or categorical variable are measures that can be classified into one of the group of categories, a class division, or people or things regarded as having particular shares characteristics. They cannot be measured in number, for example, smoking habit, gender of each employee in an organization, methods of payment, credit, cash, credit, or check. Then it is divided into nominal and ordinal. While the nominal data basically comprises of the things that cannot be placed in an order or cannot be placed in a category, or they cannot be ranked at all. For example, marital status, gender, subject in a class, and political parties, etc. While the ordinal variables are the variables which can be put in order, such as if we consider an example of an organization. So there's a lecturer, then there's an assistant professor, then there's an associate professor, then there's a professor. So there is an order to that thing. For example, education level. So someone completed primary education, secondary education, college, undergrad, postgrad. Then satisfaction grade, satisfied, very satisfied, etc. Then grades like B, C, and so on. I hope this is clear. Then we will be moving towards the quantitative or numerical variables. So the quantitative variables are measurements that are recorded in a number or a numerical scale, measured in a numerical scale, but cannot be categorized in groups. For example, number of defected items in a lot, salaries of CEOs of oil companies, ages of employees at company.
Fazal,
Yes.
can we like go a bit slowly, because someone in the chat says that we're going a bit too fast. So
Okay.
I mean, if we could slow down the pace a bit. Thank you.
Okay. Perfect. So it's further divided into discrete and continuous. So the discrete, when we are talking about discrete, assume variables that cannot be counted, always in whole number with no fractional values. For example, number of children in the family. So this can always be a discrete number. Either they are like 3 children or 4 children. They can't be like 3.5 children or 4.5 children. So it's always in a whole number, and there is no fractional values. For example, number of the cars in a showroom, number of visits to doctor, number of missing teeth. Then moving towards the second category, that is continuous variable, data that can assume all the variables between two specific values. Variable may take on fractional values. Most biomedical variables are continuous. For example, temperature, that is 98.7 or 98.6. Height is also in like fractional values like 5.4 inches and something like that. Then there is number of hours studies. It can be 2.5 hours, 1 hour. It is further divided into interval variables and ratio variables. So interval variables include their measured numerically. They can be placed in a meaningful order, meaningful interval between the items, which are usually measured quantities. Interval scale have no zero absolute. For example, temperature in Celsius scale and IQ. So IQ of a person can never be a zero, or the temperature in the Celsius scale can never be a zero. So they don't have an absolute zero. Then moving towards the ratio scale. So they are measured numerically and can be placed in a meaningful order with a meaningful interval between them. Most of the biomedical variables form a ratio scale like weight in kgs or pounds, time in seconds and days, blood pressure in millimeter of mercury, and pulse rate in beats per minute. And they have an absolute zero. So if a person is dead, his pulse rate will be zero. So they have they have like an absolute zero. So with this, I would like to move towards the case. We will be building all of our concept on the basis of this case. So an annual workshop for
Okay, sorry, Fazil. So I think, yeah, if you have any questions, you need to stop him or, seek confirmation about something or clarity, just please do so. And yeah, Fazil, you can also time and again ask questions in case if anyone needs any clarity or or if there is any confusion.
Okay, perfect, Kazi. So far, anyone have any questions? Either they want to say or they can put in chat. I have open chat so I can see that. Okay, so there is no questions so far. So let's continue with this. Annual workshop for the curriculum development was arranged for 40 high school teachers of Brooklyn, and their data was collected and recorded in form of questionnaires. And then the data was coded in SPSS, data regarding their age, gender, position, subject expertise, income, sector, and job satisfaction was recorded, along with a pre and post workshop test scores. So with this, I would like to move towards SPSS. So whenever we open SPSS, we will get a file like this. It has two views. One is data view and the other is variable view. So variable view is basically our Xerox copy of our questionnaire. So we will first make our whole questionnaire here. Then we will start entering the data in the data view. So how we add a variable? So there's a name, type, width, decimal, labels, value, missing, columns, align, measures, and row. So our first variable, as we saw in the presentation, was age, written here. So we will just go simply there and write age. And just press enter. All of these columns will be filled automatically. Then we will just arrange them accordingly. So what type of a variable age is? So age is a numerical variable, so we just keep it just like it. We close it. Then width of the age is basically how many figures we are talking about. So the 8 value is the default, so we won't change because age is like mostly 2 or 3 digits. Then it asks us about decimals, while the 2 is the standard place, but we will move it to 0 because age is never in decimals. Then there is an option of label. So basically in the section of the name, we have to write the very short name, and we have to modify it according to our needs, because in this section we cannot add space, we cannot add semicolons, or we cannot add dash. So if I had to write age of a male, so I will write age dot male, because the only thing that it's except is dot. But if I have to change it to age, and if I just, for example, put a comma and then I put male, then it will give me an error that is variable name contain an illegal character. So you can only use a dot here if you want to write 2 words, or if you can write without space. So the variables, and then there's a column for value, which we'll be seeing next, and the rest of these column are like not useful for you. It's like for detailed stats and for that stuff. So until now, and for the basic thing, you just need to know up till the values part. So moving towards the second variable, what was the second variable? So the second variable was gender. So we just add here gender, then it do its work. Then the question arises, like gender is not a numeric term, it's a alphabetical term, like it's a male, female, others, they. So we have to write that. But in SPSS, we are gonna label them. We're gonna code the gender. So in the values corner, when we click on the values, we will get the 3 dots. When we click it, it opens another window with the name of value and label. In the value, I will put 1, and in the label, I will put male. Then I will press add. So whenever I type 1 in the data view, it will correspond that I am talking about male. Then I'll put 2, and then there's female, then 3, then there's others. Then I will click OK. So I have made my second variable. So moving towards my third variable, that is position. So we will move again here, then we will add position. Then it will just, and also in the position we will be giving options, so it will be converted into a numerical variable. Like the one position is specify a lecturer, we can put the short form. Second signify assistant professor. Then the third will be associate. Then the 4 will be professor. And then okay. And then we will be having the other gender, position, subject, expertise, and income. So I'll move towards the income. So I have to write towards income. So I will write income. So for the income, we have like a special option. If we are talking about dollars, so I can go and write dollar and select dollars here and select the first option, like how much of the income I'm talking about, and press it OK, and leave rest of them same. Okay, so this is for the quantitative data, and just remember all the stuff we are talking about is related to quantitative research, and none of it is related to qualitative because it has its own tests and own stuff. So just assume if I have a variable in which I have asked about their views. So it's an open-ended question. All of these were closed-ended question having a specific options. So I just gave them the specific option. If I ask them about their views, so that's an open-ended question. And here it's a numeric. So when it's here, say numeric, you cannot write words in this part. So I will go here and change it to string. So whenever we have to write alphabets, we will change it to strings. And then it asks that how many characteristics, like how many figures of the alphabets we are talking about. So just for a safe side, we write 99. So then we cannot form any options over here. Okay, then we are done with the variable view, and we will just make a whole questionnaire here with their name, with their numeric type. So in the label, like I have to write, if I have to write is for assume if I have to send this question, I have to fill the data and send it to my teacher to check whether I have entered data correctly or not. So he won't know what position I am talking about, like what position is. So I can write the whole question in the part of the label. So like position of a teacher in school. So we can write the whole question in the label part. So far, if you have any queries or any question, you can ask. I am opening chat. And if everything is clear, just write in the chat, like give me a thumbs up or say like, go ahead. Okay, Freder, up here, best. So after we had prepared a whole questionnaire in the variable view, we can go towards the data view. When we open the data view, we can see our variables are available here, like the age, gender, position, income, and views. And these are our form numbers. So like as stated in our example, the data was recorded in form of questionnaires. And so we had it can be a physical questionnaire, it can be through Google Forms or online platforms like Survey Monkeys, etc. So I will just take the first form, and the age of the participant, for example, is 25. So I will write 25. Gender, let us assume it's a male. So we'll press 1 because we label males as 1. Then see, it changes itself directly to the male. Then it's a position. So for example, he is 25 years of age. He's an assistant professor. So we label assistant professors as 2. So we will just press 2. Then move towards the income. So his income is like $150. We just add 150 and it will add the $sign. Then his views about the job, like he said, it's good. So we can write the words here. I hope it's clear till now. I will like to do 2-3 more examples so it will be clear for all of you. Then like the next person is 45 and she is a female, so we press 2. Then she is a professor, we press 4 because we label professor as 4. Then her income is like 36 $360 dollars. Then we will like 360, and her views about the job are like she's not satisfied, so we can write not satisfied. So we will fill all of the questionnaire here like this. We can see the 1, 2, 3. The fourth class option here shows an alphabet and a number and a value. So if I press this, it will directly convert all our values into a coded form. So these are known as codes. So the code for male is 1, the code for female is 2, the code for lecturer is 1, the code for assistant professor is 2, the code for associate professor is 3, the code for a professor is 4. So we're gonna just add all of our data in our SPSS just like that, and we can change it to words or change it to the coded form, and there's no issue in the data analysis. I'm just telling you for it because sometimes it's you open and you add data and it's like that, then you will be like, what's happening, I can't understand, and something like that. So just telling you about that, and that's how we will enter all of our data. Then we will save this file on our computer. That's my computer. Then I just select the specific desktop or any folder which we're gonna, and I'm gonna save. So for this class specifically, I have prepared a data set. Let me open it. So I open it just like that. I'm gonna close the previous one without saving because I have a new data set. So it have the age, it have the gender, it have the position, it have the subject, it have income, it have pre-test scores, it have post-test score, it have the sector, and it have the job satisfaction. So the gender is 1 is male, 2 is female, 3 is other. Position, for example, is lecturer, assistant professor, associate, and professor. You can also change them if you have made a spelling mistake. You just click here and just like I just remove the R and then just have press the change. So you can change it here easily. Then press it OK. And then the subjects which we are talking about, like we have only 4 subject teacher, that is English, political sciences, social sciences, and history. Then the pre-test score, the post-test score, they are out of 20. Like they was just the way you fill your pre-test before this session. So that was like a pre-test, then there will be post-test. We will be administering the same question or more or less same question. Then we will compare the scores and see whether this session was useful for you or not. Then for the sector, we have like 2 sectors. That is, one is private sector and the other one is government sector. Then the job satisfaction, we have 3 options. Basically, disappointed, neither disappointed nor happy. So this spelling of nor is not correct here. And then there is happy. So that's our data, and we just enter a data of the 40 people as stated in our example. Like we have 40 teachers and we have all this data on our SPSS, and our data file is completed. See, we have 40 people, we have all the data completed. So far is everything clear? You need to ask anything, any question? Okay, Ariba, we have a question from you. Why don't we make a key for the views column as well? See, that matter. If in a questionnaire you have write the views and then you have just give a 2 blank lines for them to write. So everyone will have their different views. Like someone will write good, someone will write bad, someone will like is very fed up with their job. They will be like, I hate this job and something like that. So we cannot like give in options because everyone have their own opinions. But if we give the option, if we give the question of the views and then we give them the specific options, like your views, that is good, disappointed, happy, neither happy nor disappointed, then we can make a key for that. Like we can make options for that, then we can include in study. I hope that is clear for you. And everyone else, please give me a thumbs up if everything is clear for you till now. Okay, perfect. Okay. Then when I have collected this data, then there are few basic things which we can do. I have to minimize it because, okay. Then there's also, whenever you open a spaces, there will be two folders opening. One is the date, one is the file like this, and the other will be the file like this output, and it will be empty. So it will only give us the result if we apply any test on the data. So for the basic test, like for example, I want to see the ages, and I want to see what is the like the common age group, and what is the age group, what is the range of the people in my age group, like what age is the most common, and what is the average of their age. So I will just go towards analyze, descriptive stats, then move towards frequencies. I just click this and another file opens. Then I'm just focusing on the age, so I will just move age here. Then move towards stats. I need a mean, I need a median, I need a mode, I need a standard deviation, and I need a maximum, minimum, and maximum age. Whatever you need, you select according to your needs here. Then you press continue, then you press OK. So it will take you to the other file that I told you earlier. So the mean age of the participants I have is 39. The median is 34, while the mode is 45. So the mean is the average. We add all the 40 ages and divided it by 40. The median is when we arrange all the 40 variables in the form of ascending order. Then the variable in between is known as median, and like in this case it's like a 40 people, so the center point will be 20. So that the person on the 20, and while the data is arranged in the ascending order, is 34 of age, while the mode is the most common repeated number in the data. So the most common people, the mostly age, like most common age, the age is 45, while the standard deviations tell us how much we are deviating from the mean. So it is always written in the results section of the data. It's like the mean of the population was 39.5 with a standard deviation of 13.5. So the most of the participants lie in the frame in which if 39 is the center point, and we can add 13 in it too, like 39 is 49, 41, 42, 43. So the max age will be 43, and we can subtract this from 39, 29, 28, 26, 27. So the 27 till 43, most of the people lie in this age frame. Not all, we are talking about most of them. So if you want to confirm that, we can just come here and we see 27 and 40, and if we calculate these numbers, it will be more than this age. And the most common age was 45. So see, we have 6 people having the age of 45, whilst the others have different ages and different stuff. So I hope the frequencies are clear with you. I'm going to share one more example to make it like a bit clear. Now I want to see like what is the average income of the teachers in the specific town of Brooklyn. I'll go to descriptive stats, then I go to frequencies. I just take the age back and I just put the income there. And I just want to know mean and the standard deviation. Also minimum, maximum. I don't want to know median and mode. I just press continue and OK. So I got the mean pay of the teachers is 190, while the standard deviation is 55.352. Like we can add 55 and we can subtract 55 and we can get the range in which most of the people fall. Then the maximum is 100 and the minimum is minimum is 100 and the maximum is $300. Then there's an individual division for it. So this is like the basic legit basic step which we can find the mean, median, mode. We haven't applied any test yet. We haven't talked about any test yet. I'm just telling you from the raw data. If you want to see like what is the percentage of the female, what is the percentage of male, I can apply this to all of them, and I can also apply it to like multiple groups at the same time. So I'll go to frequencies and I can add pre-test and post-test both. So I can go and I can do pre-test here, then I can also put post-test. I can put all of them here. It depends on me, whatever I want. Then I press OK. So I get the pre-test workshop and the post-test. The mean of the pre-test was 9.98 out of 20. while the post-test was 14.43 with a standard deviation of that 2.3 and the 2.3. So we can do it like that. So it's just the basics of data analysis, just a little basic. We will be moving towards the test and how to apply them, what are the conditions that should be satisfied for that. So far is everything clear? I just need thumbs up. Okay, perfect. Is session going on a fine pace? You want it slower, faster? Are you enjoying it, or I'm making too boring for you? You can also tell that I want mine.
It's not boring actually. I'm enjoying it very much.
Okay, that's good.
Yeah.
Okay, just okay. Now we'll move towards the next part, moving towards back to our presentation. So we all know the case. So just giving you a background, New York have like 7 different towns, and we are talking specifically about one town of Brooklyn. Like it have 7 different towns. We are not talking about. We have like 40 teachers from a specific town. Okay, then moving towards hypothesis, because it is a term which I'll be using, so I should get it clear for you. So it is an intellectual guess which need to be proved. There's 2 type of hypothesis. One is alternative and the other is null hypothesis. The alternative is also known as researcher's hypothesis. So alternative is what the researchers want to search. So if I am seeing, I am doing a research and I say like there is a difference between the income of the government, of the teachers of the government as compared to the private. So that will be my alternative hypothesis, while the null hypothesis will be the opposite of the researcher hypothesis. That will be there is no difference among the pays of the teacher of the government sector as compared to the private sector. And whenever we apply the test, we get the p-value that tell us whether our data is significant or not. So if the p-value is significant, that is less than 0.05, then the null hypothesis is rejected. That means that the null is rejected and the alternative is accepted. So in the example that I gave you, in that case, that means there is a significant difference between the pay grade of the teacher from the government and the private sector. But if the p-value is not significant and it's above 0.05, then the null hypothesis is accepted and the alternative hypothesis, that is the researcher's hypothesis, is rejected. So in following the same example, if I got the p-value of more than 0.05, then in that case, I can say there is no statistically significant difference between the pays of the male teacher teacher of the government sector and the private sector. The p-value thingy will be more cleared in the further examples. At the moment, I need you to have a clear concept what is an alternative hypothesis and what is a null hypothesis. So if this concept is clear, just give me a thumbs up. Okay, perfect. Now we are moving towards our tests. So basically, what are the statistical tests? Like there are hundreds and thousands of them. I'm just gonna cover the basics for them. That will help you conduct like a research on the student level, because the rest of the tests like require very extensive stats knowledge. If you want to learn them, you can contact me personally and I can arrange a session for you. So we are moving towards the statistical test. They are intended to decide whether a hypothesis about the distribution of one or more population or sample should be rejected or accepted. Like the value tell us whether the difference between our population is significant or not significant. Okay, Kazi, next time I will ask questions for them. Okay, the tests are divided into 2 parts, that is parametric and non-parametric test. We will study each of them individually. So the parametric test, they are applied when the data is normally distributed and homogeneous. So the normal distribution means that is there's the mean and the median are same or almost same. So if we are doing the data analysis manually like we used to do it like 60-70 years ago, then we will use this thing. We will take out the mean and the median of the data, then we will see if they are same or almost similar, then we will consider the data to be normally distributed. But in SPSS, we used to check it via Shapiro-Wilk test. So when we apply a Shapiro-Wilk test, we get a p-value. This is the only test. I'm just repeating. This is the only test where the value of where if the value is above 0.05, that means the data is normally distributed. While if the value is less than 0.05, that means data is not normally distributed. It's opposite in this case. Only this case. This is the only test. I repeat. And whenever you apply a Shapiro-Wilk test, you will also form a histogram, and you will see the histogram should form a bell curve. Like as shown in this figure, the data is arranged, and if you form a curve and we form like a perfect bell curve, like the most of the data lies under the curve, while there are few outliers. It won't be a perfect bell curve like 100% of time, like 99% of time, it won't be a perfect bell curve, but you have to see like it forms a bell curve and most of the data is under the bell curve as compared to the data outside the bell curve. Then move towards the next condition, that is homogeneous, that is narrow standard deviation. That is used only when we are doing the manual thingy, while if you are using SPSS, we're gonna use the Levene's test. I'm gonna explain both of these tests to you just in a few minutes. And it is used when the data are measured on approximate interval or ratio scales of the measurement. And examples include one sample t-test, pool t-test, pair t-test, ANOVA, and there are a few more, but these are the basic that you should know. So mostly we just see the histogram and the Shapiro-Wilk test, and we don't apply the Levene's test because it's like very difficult to apply in the SPSS and very difficult to interpret it. So we just declare the data normally distributed or not normally. The data which is not normally distributed is known as skewed data. So we can declare if the data is normally distributed or skewed. So let's move towards SPSS. And we see just take income as a variable. We don't have to do that. Just we go to analyze, we go to descriptive stats, we go to explore, we click it. I'm taking I want to see if the income is normally distributed. So I just shift the income to the dependent list, go to stats, and see the confidence is at 95 interval. That means we are giving the 5% chance of error. Then there are plots, we click them. We just remove the tick from the stem and leaf. We just click on the histogram. We just click on the normality plots with the test, and we don't want box plot for it, so we just click none, and then we click continue, and then okay. It will take us to the file that I showed you earlier. It will take like a few minutes, and let's see. Here we have the case processing summary. That is the first table that tells us that the income, there are 40 participants and the data, 100% of the data is filled completely. So there is nothing missing. So if you are doing the analysis of like 400 people, so you are not able to check each and every box on the SPSS that it's filled or not filled. So this help us to tell if there is some missing value, so we can go and put that C. So it also gives us the mean, that is $190. Then it confidence interval, that is the lower and upper bound, various maximum range, interquartile range, just the way I told you earlier. The main thing which we are looking at is this histogram is this table of test of normality. So here he gave us two tests, that is Kolmogorov-Smirnov test and Shapiro-Wilk test. We just see the significant value. If it's greater than 0.05, that means the data is normally distributed. So in this case, the value is greater than 0.05 and our data is normally distributed, and we just click on the histogram. We double click on it basically, and it open another file, and just we click on this thing and it will create an histogram. We'll close it, and then we will close it, and then it will show us the histogram. And see, most of the data
most of the data, like the edges and all. Basically, we can also construct a histogram like this. And most of the data we can see.
Fazal, I think we have a question on the chat. If you could please.
Okay. Okay, what is the significance of normally distributed data and skewed data? I mean, what does it infer? So basically, Abhiya, as I told you earlier in the presentation, if we want to apply a parametric test, then the data should always be normally distributed and homogeneous. So we want to see which test we can apply. So before applying the test, we need a few prerequisites so that we can apply the test. While if we compare with the non-parametric test, we apply the non-parametric test on the data that is not normally distributed. I hope that it clears your confusion. Okay. So now we have histogram. And in the histogram, we can see the most of the data lie under the curve, and there are few outliers. And we can say that our data is normally distributed. I will show you another example. So to make it more clear, so the next thing I want to see if the pre-test score and the post-test score are normally distributed. I will go to descriptive stats, then go to explore, then they remove income to here, and then pre-test score move there, post-test score move there. Then we're gonna select the plots, that is histogram, normality test with normality plots with the test, and continue, and okay. Okay, whenever you do this, you will also get 2-3 other figures just like this. It's not of your use, so don't look at it. You have to just look at these two things, that is the test of the normality table and the histogram. So moving towards the next example of the pre-workshop test score and the post-workshop test scores. See, there's none of the data is missing, so that means our data is completely filled. Here we have the mean and the median, variances, range, interquartile range. We'll skip that. And then we will see the test of the normality and the significant value. SIG means significance. Significant value is more than 0.05. That means the data is normally distributed. And if we see the graph, we can plot a histogram, and we can see the data is normally distributed. It's a perfect representation of the actual data that is normally distributed, because see the beautiful bell curve. Then move towards the second bell curve, that is for the post-test workshop. And we will also put a graph, and it also shows the data is normally distributed as most of the data lie under the curve. Okay, now let's see if the job satisfaction is normally distributed or not, because I have to later on apply the test. Either I should apply the parametric test or the non-parametric test on this data. So I go to descriptive stats, explore, and I just move them back, and I just take job satisfaction here, and the plots, they are already clicked, and then I press OK. And then we have the job satisfaction, and here the significant value is less than 0.05. That means the data is not normally distributed. So we cannot apply any of the parametric test here. And we can see the histogram. We cannot plot a bell curve on this in any case. I will show you, like, even if we plot it, it is the most of the data C is outside the curve, and the value is also not significant, so that data is not normally distributed. And for this variable, we had to apply a non-parametric test. So with this, I would like to know if the concept of normality is clear. Now you are clear about the Shapiro-Wilk test. You know how to see a histogram. You know the example of the parametric test, and you know the prerequisites of the parametric test. So I just want a yes. Okay, so let me ask you guys a bit of the question. So let me see who we have here. Okay, so let me ask Batul. Batul, I hope you can hear me. Batul, what is the value of significance? Like what is the value of the Shapiro-Wilk test p-value, which we consider that the data is normally distributed or not? If the p-value is greater than 0.05, then what? It's the data is normally distributed or not? Okay, anyone else can answer if they know, apart from Batul.
Yeah, normal, I think.
Normally distributed, that's good. Just another question. So if you want to apply the parametric test, I think there are some questions. Sorry, my mic is okay, Batul. Sorry, no problem. Okay, Shapiro-Wilk test and Levine's test we're gonna see and we're gonna know. So I would just move forward with each of this tests. We will do an example. I will show how to do it on SPSS. And if you have any question or any queries, you can stop me in between or send a question in the chat. Normally distributed mean that there are few outliers of the score that carries regression towards the mean. Rama, that is technically correct. Yes, there are only few outliers while the most of the data lie under the curve. I hope this is clear. Okay, perfect. So moving towards our first parametric test, that is one sample t-test. The one sample t-test determines whether the sample mean is statistically different from a known or hypothesized population mean. So it is usually applied in the situation where only we have one sample, or we are talking about like here we have like different variables, but we are talking about just one sample, that is income. So the example is okay, so the question for the group is, what does HA mean?
Can I answer?
What does HA means? Like then the example
Alternative
Alternative
hypothesis.
hypothesis.
Okay, perfect. So the alternative hypothesis, that is my researcher hypothesis, that the mean income of the teachers of the Brooklyn is not equal to the mean income of the teachers of the other towns of New York. So the ones in this example, the known thing we have is the sample mean. We are talking about our income as I open the SPSS file, income, while while the statistically different from a known or hypothetical population mean. So the known thing is the other town, the average income of the teachers of the New York town is 150. It was published in a newspaper. So that is a known thing, and I want to compare it with my specific town, that is Brooklyn, and I want to see if their mean is equal to the mean, and if the difference between them is significant or not. So the null hypothesis will be mean income of the teachers of the Brooklyn is equal to the mean income of the teacher of the other towns. So let's move towards SPSS. And here's a variable that is income. So we go to analyze, compare means, one sample t-test. We click it here. We are talking about the sample of income. So we move our income here. Then the test variable, that is the average income of the teacher of the New York, different towns of New York. So it was 150, and it is a known value. You get it either from a literature or a newspaper or an authentic source. This thing is unknown. This thing is known. We go to options, and the confidence interval percentage should always be 95, because we always give a 5% margin of error whenever we are doing a research. We can increase or decrease it, but 95% is the optimum, and like 99% of the researchers use this. We click continue, we press OK. Then it will take towards the output file, and we will see the one sample stats, that is 40. While see the mean of our sample is 190, and this mean is a bit higher than the mean of the New York population, that is 150. as I wrote it earlier. So this said that there is a difference in the mean, but at this moment we don't know if the difference is significant or not. Then we move towards the second table and we see if the value of the significance that is significant two-tailed is 0.000. That means the value is less than 0.05. That means the difference between the mean of the teachers of the Brooklyn and the teachers of the other towns of New York is significant. So in this case, when we go back to our example, we can say, and as I stated in the earlier slide, if the p-value is significant, that is less than 0.05, then the null hypothesis is rejected and the alternative hypothesis is accepted. So in this case, we reject this hypothesis that it's equal to the income of the teacher of the other town, and we accept our researcher's hypothesis. That means the mean income of the teacher of the Brooklyn is not equal to the mean income of the teacher of the other town of New York. So we can write in the result and we can say that the difference between them was statistically significant with a p-value of less than 0.01. We never write 0.000. If it's less than that, we just write less than 0.01. So I hope the one sample t-test is clear. Give me a thumbs up in the chat if you are clear on this. Perfect. Mia is clear. Neil is clear. Hamza is clear. That's good. Perfect. Moving towards the second test, that is independent or pool t-test. And just remember that the tests which are applying on the variables, we know that these variables are normally distributed because we have already applied the Shapiro-Wilk test, and we have seen their histogram and they are normally distributed. That's why we are applying this parametric test. So the second test is independent or pool t-test. The independent sample t-test compares the means of the two independent groups in order to determine whether there is a statistical evidence that the associated population means are significantly different. So the key point is here two independent groups in order to determine whether there is a statistical evidence that the associated population means are different. So for this test, we're going to take the example where the alternative hypothesis is the mean income of the male teachers of the Brooklyn is not equal to the mean income of the female teachers of the Brooklyn. And the alternative will be the mean income of the male teacher of the Brooklyn is equal to the mean income of the female teacher of the Brooklyn. Now we'll move towards the SPSS file. We're going to go towards analyze. We go towards compare means. We're going to select the independent sample t-test. And what are the two variables? Basically, the first variable is income. And in this type of test, one variable always should have group, and those groups should not be more than two. So either I can put sector because we have two groups in the sector, that is government and the private, or either I can put gender because there is two groups in our specified data, male and female. So we go and define the group where the group one means one. We cannot write words here. We will always write the alphabets. So the one means male and two means female. We continue and we go to the option and we see it's set at 95 and we will let it remain at 95 and we will just press OK. So when we press OK, we again get the two table. In the first table, we can see in total of the 40 people we have 19 males and 21 females. The average mean of the males is $172, while the female is $206. There's a difference in the mean, and at the moment we don't know is this the difference significant or not. Okay, so when we look towards the second table, we see the Levene's equality test. Basically, this test tells us whether to look at the first line or look at the second line. So here the Levene's test hypothesis is their equal variances are assumed. That is the null hypothesis, while equal variances are not assumed. That is the researcher's hypothesis. And the value of Levene's test is 0.841. That is, in that case, we accept the null hypothesis. That is the equal variances are assumed and we reject this. If it was less than 0.5, then we should accept this. So if we have rejected this, then we won't see the second line. We will assume the test results to be the first line. So in the first line, the significant value is 0.051. And this 0.051 indicates that the p-value is not significant. So the difference between the pairs of the male and the female is not statistically significant. So we fail to accept the alternative hypothesis and we accept the null hypothesis. That means the mean income of the male teachers is almost equal to the mean income of the female teacher. Even though there is a difference between them, but the difference between them is not statistically significant. This is a bit complex, so I'm gonna show you one more example. We again go to the analyze, we go towards compare means, we do independent sample t-test. Now I want to compare income with the sector, that is the government and the private. So the one was government and the two was private. We put continue, we press OK. So again, we have two tables. So we have 20 teachers from the private sector and 20 from the government sector. The mean of the government is 189, while the mean of the private is 189, while the government is 192. And when we see the Levine's test, we see it's not significant. So that means we fail the alternative hypothesis, we accept the research hypothesis. Then we see the value of our test, that is 0.866, that is more than 0.05. So that signifies there's no statistically significant difference between the income of the private and the government teachers. So with this, I hope this test is clear and you know the basics for it. Oh, basis for it. Okay, I can get a thumbs up from everyone. I know the session is going a bit like 10, it will take like 10 to 12 minutes more because I had to start at 8:30, but few people joined late and then Kazi has to make some announcements. So it take a time. So I
no,
just...
people joined on time. So I mean, I'll take their side for today. I mean, they joined on time. It was me who took a bit of their time.
Okay, so this time you took my time. Okay, we just have 3 more tests. We're gonna do that, and then the next is paired t-test. The paired sample t-test compares the two means that are from the same individual objects of the related unit. The two means can represent things like, basically it's just two measurements from the same individual under different conditions. So there's I took your pre-test, then I give you the session videos, and I'm giving you a live session now. And okay, Rama, you have a question. If it's exactly 0.50, does this mean there is a significant... Rama, the significant value is 0.05, not 0.50. But if it's 0.05, that means there is a very weak significance. The lesser the number, the stronger the significance. The higher the number, the weaker the significance. I hope this is clear. Is it clear,
Yeah,
Rama?
it's clear. It's clear. I just mean if it's exactly like 0.05.
If it's exactly, then Rama, it's a very weakly correlated. It's related, but it's weakly.
Okay. Thank you.
Okay, then we have the paired t-test. Paired t-test, basically a measurement taking at 2 different times, that is a pre-test and a post-test, with an intervention administered between the 2 points, that is you are having this session. A measurement taken under 2 different conditions, like completing a test under a control condition and an experimental condition, giving a person medication and checking its blood values before medication and above medication. So it's a pre and a post thingy, and we apply the paired t-test on it. The purpose of this test is to determine whether there is a statistical evidence that the mean difference between the paired observation on a particular outcome is significantly different from the zero. So the example which we are taking is the mean pre-test scores of the teacher is not equal to the mean post-test scores of the teacher. while the null hypothesis will be mean pre-test score of the teacher is not equal to the mean post-test score of the teacher. Sorry, it will be equal. My bad. So we just go towards SPSS, we go towards analyze, descriptive, compare means, then the paired t-test. In the variable 1, we add our pre-test scores. In the variable 2, we add our post-test scores. We press OK. Then we get the table that is like that tells us the mean score of the pre-test and the post-test, and it shows that all the 40 people have done that post-test. Then we do when we move towards we just skip this table because that's a correlation and we are not talking about that at the moment. We are talking about the pair sample t-test, and the significant value is 0.000, so that is highly significant. So there is a significant difference between the scores of the teacher, between the scores of the pre-test and the post-test scores. So that means the intervention we put was highly affecting their behavior. So the pre-test score was low and the post-test score was high. That shows that they don't have that much knowledge before the test, and after the workshop, they got the knowledge. So that gave us a stance that there is a statistically significant difference. I hope this is clear. Give me a thumbs up so I can move forward. Okay, clear. Okay, that is the second last test, that is ANOVA. The ANOVA is also known as analysis of variance. It is a short form for that. Okay, so one-way ANOVA or analysis of variance compares the mean of the two or more independent groups in order to determine whether there is a statistically evidence that associated population means are significantly different. So basically, if any of our question have more than two variables, such as if we compare the sectors, we have government and the private sector, but we compare to our other variables. For example, I'm seeing my variable of subject. It have more than two options. It has four options. Like also in the form of the position, we have four options. So if we have more than two options in any of the question, then the test which will be applied will be ANOVA. Because in the past question, we don't have more than two categories. So in order to what will be your example, the alternative hypothesis will be at least one of the population mean is not equal to the others. We are comparing income, position, and the subject. And the null hypothesis will be opposite. We will be moving towards SPSS. We will move towards analyze, then compare means. And then we will do one-way ANOVA. We will click here. And then there's a dependent list and there's a factor. So in the dependent list, I want to put the income. I want to put the jobs income, and I want to put the subject, and I want to position in the factor list. You can also put subject in the factor list or anything you like, but I want to see if the income, subject, and the position means have any significance between them. Then I just press OK, and then just I get this table, and that show that there is a significant difference observed between the income and the position, because our factor was position, but there was not significant difference between the subject and the our factoring variable, that was the position, like the position of the lecture, either a lecturer or what. Now here we just know that there's a difference. We doesn't know which group has the difference. Like either the difference is between the lecturer and assistant professor, like their income is significantly different, or either it's between the assistant and associate professor. So for this, we will go back again. We will do analyze. We will go compare means. Then we will click one-way ANOVA. Then we will go to post hoc, and we will apply the LSD test. There are a lot of tests for a different reason, but only which I will be teaching you now is LSD. You will press LSD, continue, and OK. Then we will have the same table, but also we will have another table that show in this there's a significance value for each of the specific group given. So there is not a significant difference between the income of the lecturer and the assistant professor, as this value is more than 0.05, and same with associate professor, and the value is more than 0.018. While there is a significant difference between the pays of the lecturer and the professor, and the value is significant, 0.000. So this test help us to determine, like, in subgroups, which group is like specifically different from the others. And so on. We can see the differences here, and we can infer that there's a statistically significant difference between the pay of the professor and the lecturer, and the professor and the assistant professor, but there is not much significant difference between the professor and associate professor, while for the subject C, all of the p-values are non-significant. So that's how we use ANOVA in the, so in this case we get the significant, so we accept our alternative hypothesis while reject the null hypothesis. So here we are done with the parametric test. And give me a thumbs up if you understand the ANOVA and all the parametric tests. Then I'll move towards the non-parametric test, and it is only one. Okay, Shuvra Sarkar, in the end of this presentation, I will be sharing some links. If you want to do further reading, you will also get some data set over there. You can download and work on SPSS. So moving towards.
Okay, thank you so much.
Okay, so moving towards the non-parametric test. So they are applied when the data is neither normally distributed nor is homogeneous. So the Shapiro test value will be less than 0.05, and the histogram won't be perfect. So now we know the data is not normally distributed, and we have to apply the non-parametric test. The common example is chi-square, Kruskal-Willis test, Mann-Whitney test. But the most important which I'll be teaching you is chi-square, and the rest of the tests need like an extensive knowledge. So if anyone have specific interest and want to learn for that, we can arrange that after this whole 6 weeks are completed, because I'm also advising a group. So it won't be possible for me to arrange in between. So moving towards chi-square. The chi-square test of independence determine whether there is an association between the categorical variables, whether the variables are independent or related. The requisite should be there should be two categorical variables, and both of these variables are not normally distributed. So that means we will be applying non-parametric test. These are categorical variables because we have different categories here. Independence of observation. So they are not related to each other. There is no relationship between the subject in the each group. The categorical variable are not paired in any way. So they are not paired. They are not pre or post test score. And it is mostly used in a larger sample size. I'm just showing you how to do stats, so that I just created a sample size of 40. Expected frequencies in the each cell should be less than 1, and expected frequency should be EMF. I will teach you this when I will move towards SPSS. So the example here we have the sector is associated with job satisfaction, and the alternative the null hypothesis will be sector is not associated with job satisfaction. We will move towards SPSS. We will go towards analyze. We will analyze, then we will move towards descriptive stats, and we will move towards cross tab. Chi-square doesn't have a separate tab, so just remember you go to cross tabs. Then you put one variable in the rows and one in the columns. It doesn't matter whichever you put where. Then we move to we click on stats, and we just click on chi-square. There are a lot of tests that are not related to you right now, so just click chi-square and continue and press OK. So when you press OK, you get these three tables, and the table which we only want to be looking at is the last table, that is the chi-square test. And here the Pearson chi-square value is 0.10. That means the difference between them is not statistically significant. So in this case, we reject the alternative hypothesis and accept the null hypothesis that the sector is not associated with the job satisfaction. If the value was less than 0.05, then we accept that there is a difference. Then another question like which sector has a difference. So then we move towards this table, and we determine by their means and their percentages. Like whichever group has the more representation, that group will be having the more difference. So with this thing, I hope the chi-square is clear. Give me a thumbs up. And now you know how to apply chi-square and when to apply chi-square and how to interpret the results. Waiting for your thumbs up. Yes. I will just take 3 to 4 minutes more and then we will finish. So here are few of the links. You can take the picture of that, and this session is also being recorded, so it will be uploaded on YouTube also. And I can also send you the data set which I worked on with you here in your presence. And you can also repeat this while seeing the video and get perfect on it. These are some of the guidelines which can give you the details of the test. They will have some of data sets on which you can work on, and these have a lot of data set basically you can work on. Then they have also examples and you can compare your results with them. And if you have any queries for anything, and you can also save the output variable, like you can see all of this test, and for the next time whenever you are writing results or something. And this conclude my presentation, but I can also share the presentation with you guys, and this conclude. And now I would like to know your reviews about this session. Was this helpful? Is this thing was new for you, or is anything was like very hard for you, or anything you need more clarity about? You always can contact me through email or WhatsApp. Like one of the group is here that know me like personally, because I'm the advisor. So I'm just waiting, either write in chat or say something like, how was the session? Was it useful? Was anything new for you? One last question in chi-square, we don't have to specify the yes, we don't have to specify the dependent and independent variable, Ariba. SPSS software is available on internet. You can go and download a crack version of it, or either you can take it from your own universities, or universities have an access. You can learn from YouTube. I'm from a medical background and I don't have any knowledge of stats. Like I have never studied stats either in school or in college, but I learned it because of just my own interest, and now I know SPSS. Okay, there was so many. Okay, I am very happy that this topic and this session proved to be useful. There is one session left for this module, that is the session on the data presentation. I will be recording it and will be uploading it by tonight, like in few hours, like 1 or 2 hours on YouTube. And after that session, you all are requested to please fill the post-test questionnaires, because it will help us determine whether these sessions were useful for you or not. And if you have any queries, any feedback, any constructive or anything feedback you want to give, if you don't like anything, if anything wasn't clear to you, you want anything, you can always contact me or contact the communications email, and they will connect you with me. And if you want to learn the advanced stats, you can also contact me and I'll be happy to help you all. Okay, by this, I think we conclude our session. Sorry for the delay of like 20 minutes. And it was really nice seeing you all and working with you all, teaching you all. I hope you will apply this thing, because people usually forget SPSS, so don't forget this thing.